Boys and girls, children of all ages, we have a test on Thursday. So here's what it's going to include. You guys have your practice sheet from last week. All of this is fair game. So if you have questions, let me know. But finding slope, finding the y-intercept, going from 2 points to slope, going from an equation to x and y intercepts, and graphing it. All of that's on there, as this will be as well. So, first things first, we have to get y by itself. That's going to be important for today. We subtract 3x from both sides. That leaves me negative 2y equals negative 3x plus 6. We divide each individual thing by 2, or by the negative 2. That leaves me 3 halves x, bless you, minus 3, bless you. What I will always do as I'm teaching this is say, what is my m, what is my b? M stands for what? Slope. M stands for slope. My slope is 3 halves, that's my rise over run. What does the b stand for? Y-intercept, which is negative 3. So now when I graph, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. We start, this is my starting point. Negative 3, my slope is positive, which means we go up 1, 2, 3, over 1, over 2. That's a pretty straight line. Then I graph. Does it look correct? Well, negative 3 going uphill. For the most part, we can say, yeah, we're A-okay there. Questions on this one? Thumbs up if we got that one right. Okay. Number 2. Darn it. Balance point. Add 3x to both sides. That leaves me 6y equals 3x plus 6 divided by 6 from each individual thing. Y equals 1 half x plus 1. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. M is 1 half, that's my slope. My y-intercept is 1. I start at 1. I'm going up 1 over 2. And I've got it. Questions, concerns, problemos. Okay. Okay, so now we'll play the game. So Cole, my son, was in here this morning, and he was drawing a park that he went to this weekend. So I will tell you that there are some monkey bars, there is a slide and curly slide, and then there's a climbing thing with a flag and a slide. Somebody figured it out earlier what park it was. Does anybody know what park he was at?
I forget the name, but I know where it is.
Where is it?
Is it off of Douglas Street?
It's very close, yes. This is Lee McKeegan Park.
Yeah.
I had a freshman this morning go, that's Lee McKeegan Park. Without me, I was like, this is a picture of my son's playground. He's like, that's Lee McKeegan Park because I know that flag. I'm like, that was very good. I was like, I'm going to tell my son that. He's like, I was there too. I was at the skate club. It is October 7th. A week from today, he will be 7.
Oh, wow.
Okay, so we are talking about parallel and perpendicular lines today. What do we mean by parallel lines? What are parallel lines?
Side by side, don't touch.
They don't intersect. So touch is fine, but we're gonna try to speak like mathematicians. They never intersect. They go forever and ever and ever and will never cross. That's what intersect means. What about perpendicular?
They intersect.
They absolutely intersect to form what? What kind of angle?
90 degrees.
A 90-degree angle. So when two lines intersect, they are perfect 90 degrees on all of those corners. So parallel lines. Same slope, different y-intercept. Okay, so if we are finding parallel lines, you will immediately be able to know that they're parallel because they have the same slope. Perpendicular lines. opposite reciprocal of the slope. And I know that doesn't make much sense yet. Copy it down, it will make sense, I promise you. If you're starting to learn, I might say things that you're like, it doesn't quite make sense until it does. Okay, I never leave you hanging. Okay? So, an example of parallel lines, y equals 3/2 x plus 2, y equals 3/2 x minus 1. 1, 2, 3, 3, 4, 1, 2, 3, 1, 2, 3. So we're going to call this line 1, we'll call this line 2. Here's line 1. Up. 1, 2, 3, over 1, over 2. So there's line 1. Everybody with me? Line 2, negative 1. Up 1, 2, 3, over 1, over 2. Obviously, it's not perfect, but can you tell that those lines, for the most part, I mean, they're parallel. If it was a perfect graph, I had a ruler, all of that, should I have gotten this and probably made straight lines? Yeah, but because I made the graph itself, it's not going to be perfect. Okay? So, let's talk about that perpendicular line. So these are parallel lines. You should have that copied down. I mean, if I did it, you should have it. I also need you guys to hold me accountable. So I've been doing a lot of research and we're trying to figure out, and I've been praying a lot about my anxiety and my stress. And since I've come back, especially since I've come back to school, before I was working from home. I had 1 or 2 cups of coffee, my 1 or 2 Monsters. Since I've come back to school, I had my coffee at home and then I drink coffee throughout the day. Like I'm having 5 or 6 cups of coffee here and then still my 2 or 3 Monsters. So I'm like, okay, I'm gonna cut out caffeine. So I've had a cup of coffee today and I'll have my Monster in my last hour. But I already have a headache, so if I start getting grumpy or you start seeing my mood change, you're gonna be, Mr. H, check yourself. Is that what you kids say? No?
Sure.
Kind of. I don't know what you guys say. I'm old. I had somebody walk up to me, one of Cole's friends. He goes, how old are you now? Because you're really old. I'm like, wow, you're really small. I can kick you off this rock. I didn't, but I thought it. I was like, I can just boot you off this rock, little kid. But I didn't. Okay, opposite reciprocal. So here is perpendicular. Y equals 2x plus 3. Notice it doesn't say anything about the y-intercept. This has to have different y-intercepts. Because if it doesn't, it's going to be the same line. Because the slopes have to stay the same. Now, what's the reciprocal of 2? Not 1. Reciprocal means we flip that fraction. So what's the reciprocal? Did you get your haircut?
Yep.
Looks good.
Yeah.
What's the reciprocal of 2? Remember,
-2.
no, that's the opposite.
1/2.
What is it?
1/2.
1/2. Well, what's the opposite of 2? You said negative. So the opposite reciprocal is negative 1/2 x. And then it doesn't matter what your y-intercept is. It can be the same. The only thing that matters are the slopes. Well, let's take a look. So we've got +3 for both of them. Down 1 over 1 over 2. And we're going up. 1, 2 over 1. If I got out my handy dandy compass, protractor, whatever, protractor, and I put it here, though it's not perfect, that's pretty darn close to 90 degrees. You know what that means? That they are perpendicular. So, the key, and I know this wasn't a long lesson, the key don't laugh.
I won't.
Okay, good. I knew before I even looked that you were on the verge. I knew. Okay, the key here is all about slope. Parallel lines, the slope has to be the same. Perpendicular, opposite reciprocal. So, I just put my markers back. Let's do y equals 5 half x minus 2. Two things. I want a parallel line equation, and I want a perpendicular line equation. So write an equation that's parallel and perpendicular. It shouldn't take long. Tomorrow, you need your TIs. You need to have your calculators. Okay, I have one extra. We're doing stuff in the calculator. So you two might have to share it. Okay, which is fine, but you two might have to share it. Make sure you bring yours. Okay. So, for parallel, what's the only thing that needs to happen? To write an equation for parallel, what needs to happen?
Same slope with different y.
Oh, okay, so if I was writing this, I would have y equals 5 halves x. Give me a different,
Plus 2.
plus 2. Plus 222. Those are still going to be parallel. It doesn't matter. As long as the y-intercept is different and the slope is the same. Now, for perpendicular, what will be my slope?
2/5.
Not just 2/5. Negative. It's the opposite. So if it's positive, it has to be negative 2/5 x. And we can keep the same number there. Okay, now, there's not a lot here. I know there's not a lot here. I want to work through this together. There's a lot. Okay, so we are doing right now the evens. Just get started, work together.
The whole bit of like.
The evens, yeah. We've got a lot of time. It's not homework, this is classwork. Our class isn't over for another 30 minutes, I think. We've got a lot of time to work on this. It is 10:31. We've got 20-ish minutes, 25 minutes to work on this. Okay? So, let's look at it. Number 2 says, find the slope of a line parallel to each given line. So finding the slope, y equals negative 3 halves x plus 2. If it's parallel, it has to be the same. So what's the slope? No, it just says find the slope. No, that would be perpendicular. Parallel is the same. So for number 2, the same slope is negative 3 halves. What about for number 4? What's the same slope to make it parallel? Negative 3. But when we jump down to number 8, find the slope. Ooh. Well, it's negative 2. So we flip it. It's 1/2. And it's opposite. So from negative to positive. So for number 8, it would be positive 1/2. Everybody with me? Now, when you get to 14 through 24, you got to get them into slope-intercept form. Okay. Go ahead. I will be walking around helping you all out.